Here we're going to solve problem C from Pinely Round 2, MEX Reptition. In this problem, we have an array of n pairwise distinct integers, a1 through an, that are between 0 and n. And we have an operation. For each of these ai, we replace ai with the MEX of all of the ai's from 1 through n, respectively. The MEX is defined as the smallest non-negative integer, which does not appear in the collection so far. And we have up to 10 to the 5 test cases, up to 10 to the 5 numbers, and a k, which is the number of operations, which goes up to 10 to the 9th. And we have to print all n elements of the array after applying k operations. In this problem, we know we have exactly n pairwise distinct numbers, each of which are between 0 and n. Between 0 and n, we know that there are exactly n plus 1 numbers, out of which we use exactly n in our ai array. Now let's see what the problem is asking. First, let's take a look at what the MEX is. So say we have an array with numbers 0, 1, and 3. Then the MEX is the smallest possible number that's not included, which is 2, clearly here. Knowing that we have n plus 1 numbers between 0 and n, we know that the MEX of our array is simply the number we've excluded between 0 and n. Because every other number is included in our array, and we want the smallest number not included. Now let's see what we can do with this problem. Say we have k equals 2 and n equals 3, or we're operating our operation twice, and we have our three numbers 0, 1, and 3. Let's see what happens when we use our operation once. Here, clearly the MEX of 0, 1, and 3 is 2, because it's the smallest number between 1 and 3 that's not included. Then, after applying our operation, we would get 2, 1, and 3, of which the MEX is 0. Then, we'll replace the second element with 0, so we'll be left with 2, 0, and 3. And here, the MEX is 1, as it's the smallest element not included. Finally, we'll do this once more. We'll apply our operation and get 2, 0, and 1, where the MEX is 3 currently. Now let's use our operation the second time. In the first step of our operation, we're replacing the first element with the MEX. So we originally have 2, 0, and 1, and we're replacing the 2 with the MEX, which is 3. So we'll get 3, 0, 1. Now we have 3, 0, 1. With 3, 0, 1, we know that the MEX is 2, because 2 isn't included. So we replace the second element, 0, with 2 in the second step of this operation, or we have 3, 2, 1 with the MEX of 0. Finally, we'll replace 3, 2, 1 as the last element with 0. So we're left with simple 3, 2, 0. Thus, since we know we have a1 through an, and we have a MEX, what we're essentially doing is rotating our array. We're bringing the MEX to the start, and the second element just becomes whatever a1 was, and so on. And our MEX at the end of an operation becomes an. To do this, we know each operation is essentially a rotation of our array with MEX appended to it. We also know that with our MEX appended to it, we have an array of n plus 1 elements. So after n plus 1 rotations, we go back to the original. So, since k is so large, we can just deal with k mod n plus 1. And this is essentially solve the problem. We simply need to rotate our array by a factor of k mod n plus 1, which we can do very fast through code. Let's code this problem up. Initially, we have an integer t, which is the number of test cases. We'll input into this t, and we'll iterate through our t test cases with the while loop. In each of these test cases, at the start we have an integer n and an integer k. For the sake of simplicity in this problem, we'll keep these as long longs, since later we're going to want to deal with the sum of the elements. So we'll input into these, and we'll keep a long version of the total sum. The difference between this and the sum of our elements in our array is simply the MEX. So we'll keep our current sum, which is 0, and we can find our current sum just by inputting into each of the elements in our array and adding into our current sum. We'll also create an array of elements, which we'll call nums. As you can see in this for loop, we'll add our number to our array and add our number to our current sum. And our current MEX is just the total sum minus our current sum. And we can append this to our array, which will then rotate to get our k times to get our answer. Let's work on our output now. So how can we rotate our array k times? First, let's make sure we can use k properly. So let's mod it out by n plus 1. As in n plus 1 rotations, we go back to the original. Next, we'll rotate backwards by k, and then we'll add n plus 1 to make sure we're left with a positive index, and we'll mod out by n plus 1 to get our output. And finally, we'll output our n line. Let's run it on the sample input, and as you can see, we get the correct answer. Now let's submit this to CodeForces, and as you can see, we get the correct answer. Thank you for watching.